This is the biggest circle. Go right up above it, and we're going to draw number 2 as that triangle. We're going to call it triangle CED. Now pay attention to where the letters are. And we're going to mark this and this as our congruent sides. So these two are going to be your congruent angles. See, these are your legs. This is a leg. This is a leg. And this is the base. So it's not always going to be sitting on its base. And we're going to label a couple more things. We're going to label CD as 18 inches. That's this leg. And we're going to label this angle up here as 106 degrees. And we want to know the measure of segments ED, so you don't put a bar over it. And we want to know the measure of angle E. And we want to know the measure of angle C. These two are the same. Well, now, what's the arithmetic behind finding these two angles? If you know this is 106, how could I go about finding angle E and C? What would you do first? How many degrees in a triangle? 180. And if we take the 106 away from it, we get 74 degrees. If I say that this angle's 106 and this one's 74 and this is 74, that's more than 180. But remember, once you take this away, and this is the hardest of these kind of problems, then these two angles have to be the same. What do I need to do to that 74? I need to divide it by 2, and I'll get 37 degrees. And if you check it, let's see, let's put 37 degrees, 37 degrees. And if you add 106 plus 37, you do get 108. Now, the legs are the same, and that's what you were asking, Trinity. If this leg was 18 inches, then this one is 18 inches. I do like when they put units on them. Number 3. And we're going to use the one right above it. So just draw that triangle. Now, it's real obvious that these are the legs. This is a leg. This is a leg. This is the base. And this is triangle KML. And if these are the same, then these two angles are the same. I got to put some information. Okay, they're going to give me that angle K is 80 degrees. And they want to know the measure of angle L. And they want to know the measure of angle M. This one's a little bit easier than that one up there. And then they're going to do the legs, and they're going to call this leg 13x minus 18, and they're called this one 9x plus 2. It's very similar to what we did in number 1. So then they want to know x, we'll put blanks, and they want to know the length of KL, and they want to know the length of LM. Now, we can't find KM because we don't know anything about it other than it's the base. Let's do the angles first. That's your easiest. Angle M, it's going to be what? It's going to be 80 degrees also, and I'm going to label it that way. I like that. I'm a visual person. I like my picture, and so I know if these two are the same, the angles across from them are the same. Now, how can I get L? Well, you can add them together, or you can do it like that, or do minus 160 if you want to do it that way. You're going to get it either way. I think it's 20 degrees. And so angle L is 20 degrees if you want to label it. It's easy to check. 80 plus 20 plus 80 is 180. Now, pay attention to where your isosceles triangle is, because here's your legs, and we know the legs are the same in an isosceles. So let's set 9x plus 2 equal to 13x minus 18. Minus 9x minus 9x, and I have 2 equals 4x minus 18. Add my 18. I get 20 equals 4x, and x is 5. So let's fill that in. Now, watch carefully. These are equal. 9x plus 2 and 13x minus 18 are equal. So to me, KL looks the easiest. 9 times 5 plus 2. I bet you can do that in your head. 45 plus 2, that's 47. They didn't put units on it. I wish they would. Inches, whatever. And so if KL is 47, then LM is 47. You again can plug it in, 13 times 5 minus 18, and it will give you 47.